So here with area and perimeter on a grid, and so just a quick review of what area and perimeter are before we get started. It does say, do you remember how to find the distance between 2 points on the coordinate grid? And our preferred way of doing that would be the distance formula. Which can be written a couple different ways. My preferred way is to do d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. Now that that's there, let's go ahead and talk about area and perimeter. Area is the amount it takes to fill something. Perimeter is the distance around something. So we are asked to find the area and perimeter of this rectangle. And so there are formulas that are associated with finding the area and perimeter of a rectangle. The formula for the area of a rectangle, or yes, a rectangle, is going to be length times width. And so we could say that this rectangle has a known length of 1, 2, 3, 4, 5 units because we can count it. So the area of this rectangle is going to be having a length of 5. That is multiplied by the width, and we can count 1, 2, 3. Now the reason we can count that length and that width is because those are vertical or horizontal lines on the grid, and so they do not need the distance formula to find them because they're not slanted. And so the area is simply going to be 5 times 3, and when we do area we should label it in square units. My iPad chose to disappear again. I'll be right back with it. Okay, the technical glitch has been averted. So, area is 15 square units if we were to find the perimeter of this rectangle. There's a couple formulas you could use to do that. One of them is 2L plus 2W. That's 2 times the length plus 2 times the width. Instead of that, I prefer to say I have 2 lengths, so L plus L, and 2 widths, W plus W. Both of those formulas will produce a correct answer. It's really a personal preference. For me, again, I prefer the one on the bottom. So the perimeter of this rectangle is going to be the 2 of the lengths. We decided that the lengths were 5. So 5 plus 5. Because we would need 5 on both sides to be able to walk around this thing. Then 2 widths, because we would need to go 3 on the top and 3 on the bottom to walk around this thing. And if you want to rearrange it so you're thinking about it as 5 plus 3 plus 5 plus 3, you can think about it that way also. I'm going to rewrite it that way just for people that need that to make sense of it. 5 plus 3, so down the side across the bottom, plus 5 takes me up the right side, plus 3 takes me left across the top. And so again, that goes 5 plus 3 plus 5 plus 3 to walk around this rectangle. And so either way, whether you add 5 and 5 first or you go 5 and 3 first, either of these two lines will produce the exact same answer, which is going to be 16. And 16 perimeter is measured in just regular units. Okay, that's it for rectangle. If you need this, pause it before I move on. For a triangle, things get slightly more challenging. Not bad, but recognizing that in this case we do not have the same sort of setup that we did for the rectangle. Not all of the lines are vertical or horizontal. And so you may remember from previous grades that the area of a triangle, the formula is area of a triangle is equal to, let me put my triangle in there, area of a triangle is equal to length times width divided by 2. Another way that you might see this is base times height divided by 2. Another way you might see this is base times height divided by 2, like this. All of those are equivalent and they would all produce the exact same result. It's just important to recognize that different teachers and different students have their favorites and all of them will work exactly the same. I will choose to stick with the first one. So area of a triangle is my length is going to be 1, 2, 3, 4, 5, 6, 7, 8 units. So my length is 8. Now the tricky part here is to recognize the width or the height, depending on how you want to call it. The height is going to be from the highest point of the triangle straight down. So from point A, down 1, 2, 3, 4 units. So our height is going to be 4. So we have, for length times width, we've got 8 times 4. We would have that over 2. So area of a triangle is equal to 32 over 2. Area of this triangle is equal to 16 square units. And again, if you used either of the formulas that I am highlighting in green, either one of those would produce the exact same result. So that does it for area. Now let's talk about perimeter. Perimeter gets a little bit tricky. Now we know that across the bottom we have 8 units. And so that's pretty self-explanatory. We would have to walk, if we had our little person here, let me fix that. Our little person here would have to walk 8 units that way to get across this side of the triangle. But what about coming up this side of the triangle? We have no way of knowing by looking at the picture what the length of that side of the triangle is, and so we're going to have to use the distance formula. Now what we've got here at C is we have the point 4, negative 1, and at A we have the point negative 2, 3. And so if I have those 2 points, I could go ahead and use the distance formula to figure that out. So I'll go ahead and call that line segment AC. And so line segment AC has 2 points. It has negative 2, 3, and 4, negative 1. I'm actually going to move that to the left a little bit so that I make sure I have enough room to do the distance formula a second time, because I'm going to need to. Alright, and so throwing the distance formula in there, I will pause while I do that because it takes a moment to do that and I don't want to waste your time. So I've gone ahead and thrown in the distance formula, and recognize that I do highly encourage you to do this, to put the template down without numbers in it so that you can have a way to kind of organize your information. And I did forget to label these points up here, which is also like mega important, so I'm going to take a moment to move this down a little bit so that I can label those points. And so negative 2 will be my x1, 3 will be my y1, 4 will be my x2, negative 1 will be my y2. And so x2 minus x1 is going to be 4 minus negative 2. y2 minus y1 is going to be negative 1 minus 3. And again, I've spoken to you in class about this whole double negative thing here behind the 4. 2 negatives sitting next to each other like that does in fact make a positive, and so if you want to go ahead and just do this at this point, that is helpful. It saves you having to write another line and saves you some room on the page. So we'll have d squared is equal to 4 plus 2 is 6, and negative 1 minus 3 is negative 4. So d squared is equal to 36 plus 16. D squared is equal to 52. And so looking at this, our last step, as always, is to take the square root of 52, square root of both sides actually, so I'm going to scoot this over here since I ran out of room. D squared is equal to 52. We square root both sides, and we get the distance is equal to 7.21. So coming back to our figure, we know that this side is 7.21 units long. That helps us with the perimeter, but we still need to know this side over here. And so I'm going to go ahead and label that point B as the point we are missing, -4, -1. And now I can decide what I want those points to be in terms of x1, y1 for line segment AB. And so we'll have line segment AB, and we will have our first point is A, -2, 3, and our second point B is -4, -1. Alright, and as I did previously, I'm going to pause while I do the distance formula work in terms of setting it up, just because it takes a while. Okay, and so I have my templates set up and all that. I am going to label these with my x's, very important. x1, y1, x2, y2. And so we've got x2 minus x1 is -4 minus -2. y2 minus y1 is -1 minus 3. And similar to the one previous, we do have those two negative signs next to each other right now. We can turn that into a big plus sign. Saves a little bit of room later. We have d to the power of 2 is equal to -4 plus 2, which is -2, plus a -4. So d squared is equal to 4 plus 16. D squared is equal to 20. And similarly, I'll move this over to the side so that I can have a little bit more room. D squared is equal to 20. We square root both sides. D is equal to 4.47. So coming back here on the figure, this side is going to be 4.47. And so for perimeter on this one, I am going to go ahead and erase a little bit up here so that I've got some room. Perimeter of this triangle is equal to all three sides added together. So we will go 4.47 plus 7.21 plus, need more room, 8. And so if I was to add all those up, the perimeter of this triangle would be equal to 19.68. And so that's how we go about finding the perimeter of both a rectangle that is sitting with its vertical and horizontal lines, and how we go about finding the perimeter of an area and perimeter of a triangle. Quite a lot of work, but kind of fun.